The switches are digital, which means that they can only ever be in one of two states, true or false. There is also an electrically powered mixer inside the tank, which starts working for a defined period of time, mixing the two liquids together after the tank is filled. We also have a discharge valve in the bottom of the tank, which controls the draining of the liquid from the tank. Okay, now let's see what the program should do. This lower level switch has an open contact inside it. When the level of the liquid drops to the level of the switch's position, the contact closes, sending a 24-volt DC signal to the PLC input. We want to write the program so that when the level of the liquid reaches this minimum, the pumps will be activated and begin filling the tank with the liquids. The pumps continue filling the tank until the level reaches its maximum at the higher level switch. When this happens, the open contacts in the switch will be closed, and another 24-volt signal will be sent to the PLC input, telling us that the tank is full. When this signal has been sent, first, the pumps should shut down so that no more liquid enters the tank, and then this mixer should be turned on. We want the mixer to operate for 7 seconds, mixing the liquids that have been pumped into the tank. After 7 seconds, the mixer should automatically shut down, and this discharge valve should open. With the valve open, the liquid will be discharged from the tank and transferred to another location within the factory to be processed. When the level of the liquid in the tank drops to the minimum set level of the lower switch, the switch contacts will close again, thus starting a repeat of the cycle. Okay, so now we need to click on the Somatic Manager desktop icon in order to start writing the program. Somatic Manager is a program which manages sub-programs of Step 7. To start our programming, first, we need to create a new project by clicking on the New icon on the toolbar to open the new project window. In this window, we enter a name for our project in the name field. We'll call this project Mixer and enter it here. The path to our saved project is shown in the storage location. However, we can use the Browse button to navigate to a different location other than the default. Okay, after creating the project, we click on its name to highlight it. Then, from the Insert menu, we select one of these stations, dependent upon the control system that we intend to use. As we discussed previously, we will be using an S7300 PLC to control our machine. So, we need to select the second option shown here, which is Station 300. After selecting this option, we see that a subgroup named Somatic 300 has been added to our project. Next, we click on this hardware icon, which takes us to the hardware so that we can configure the modules we need for the PLC. Our PLC is an S7300. So we need to select the relevant modules from Somatic 300 subgroup here. First of all, we need a rack into which we will mount the modules. To insert the rack, open the Rack 300 and double-click on the rail to add it to the left window. As you can see, this rack has 11 slots. We need to install a power supply in the first slot to power our PLC modules and turn them on. To do this, we open this PS300 folder and double-click on this 2-ampere power supply to insert it into the first slot of the rack. Note that all the listed PLC modules have an order number or part number, which is displayed in this lower box when each module is clicked on. In real-world projects, the order number of each module that we select should match exactly the module in the enclosure, but as this is a demonstration project for training purposes, we can ignore that requirement for now. Okay, in the second slot of the rack, we always insert the CPU module. To select the desired module, we open this CPU 300 folder, which opens to show us all types of 300 CPUs. We want to select a 316 CPU, so we need to open this CPU 316 folder and click on the relevant part number to insert it into the second slot in the rack. Now, in addition to these two modules, we need an input and an output module, both digital. The input and output modules are both categories in the subgroup SM300. To insert a digital